In this video, we're going to look at simplifying radical expressions by dividing by rationalizing the denominator. So as mentioned in the previous video, a radical is simplified when it meets these three criteria. 1, there's no perfect powers of the index left under the radical. 2, there's no fractional radicands. And 3, there's no radical in the denominator. We call that rationalizing the denominator. Excuse me. We're going to look at some techniques right now on how we can rationalize the denominator when there's just one single term in the denominator. So for letter A, we have 1 over the square root of 3. Okay, cool. How do we get that radical out of the denominator? 3 is not a perfect square. Well, what we can do is, this is a fraction. Think about what we can do with fractions. We can multiply the numerator and denominator by the same amount, and that doesn't change the value of the fraction. And that's exactly what we need to do here. So what can I multiply the square root of 3 by that would clear out that radical? Well, I need 2 factors of 3 for it to cancel with the square root. So I just need to multiply the denominator by the square root of 3. If I multiply the denominator by the square root of 3, I need to do the same thing to the numerator. Now in the numerator, 1 times the square root of 3 is the square root of 3. And in the denominator, the square root of 3 times the square root of 3. However you want to justify this, that's the square root of 3 squared or the square root of 9. No matter what, it ends up being 3. It's not an issue when there's a radical in the numerator. We can't get the radical out. We're always going to have a radical either in the denominator or the numerator in this case. And the tradition is that we rationalize the denominator. So this would be our final answer. You might be tempted to want to cancel out the 3's, but remember that's not a 3. That's the square root of 3. We can't. You can simplify things that are under radicals. You can simplify things that are out of radicals, but you can't simplify things under radicals with things out of radicals. So that's our final answer. In letter B, we have the square root of 6 over 5. The first thing I might consider is, okay, can I simplify 6 over 5? And the answer is no. So what I might do is I might rewrite it as the square root of 6 over the square root of 5. And now let's rationalize that denominator. So 5 is a prime number. The only way we're going to get that radical out of the denominator is if we multiply it to the square root of itself. So we're going to multiply the square root of 5 to the square root of 5. If I do that to the denominator, I need to do the same thing to the numerator. In the numerator, the 6 and the 5 are both under the radical, so we can multiply those together. This, 6 times 5 is 30. And then in the denominator, the square root of 5 times the square root of 5 ends up being 5. So our final answer here is the square root of 30 over 5. I know it's tempting to want to simplify. You gotta calm that temptation down because you can't. It's not 30, it's the square root of 30. It's a totally different number. All right, in letter C, we have 2 over the square root of 7. In this case, we can't simplify even if they had common factors because one's under a radical and one's not. So what would I multiply the square root of 7 by to clear out the radical from the denominator? I need to multiply by the square root of 7. If I do that to the denominator, I need to do the same thing to the numerator. Multiplying straight across, we have 2 times radical 7. We can't combine them. 2 is not under the radical, so we leave them just 2 as the coefficient now. The square root of 7 times the square root of 7 is 7. And lastly, letter D, I just wanted to look at one example where we had something other than a square root. So in this case, we have a cubed root. So what would I need to multiply 5 by to clear out the cubed root? Well, remember, we need to look for, if we're going to clear out a cubed root, we need a perfect cube. So I can't just multiply by the cubed root of 5 because 25 is not a perfect cube. A perfect cube that 5 goes into is 125. Well, we would need to multiply 5 by 25 to get to 125, or you can think of it as 5 squared, whatever makes more sense for you. If you think of it as 5 squared and this is just 5 to the first, you can see that it's going to be 5 cubed. If you write it as 25, you can multiply 5 times 25 is 125, which is a perfect cube. In the numerator, since I don't have to worry about any simplifying or anything, I'm going to actually write the 25. Now 1 times the cubed root of 25 is the cubed root of 25. And then in the denominator, the cubed root of 5 times the cubed root of 5 squared would be just a regular 5. And that would be how we rationalize the denominator. Taking this up a notch with rationalizing the denominator, let's look at cases. In all the previous examples, they were all prime numbers. I want to look at something that's not a prime number. So here in letter E, we have 2 over the square root of 12. We can't simplify because 2 is not under the radical and 12 is. But we can't simplify the fraction, but what we might want to check is, can we simplify the square root of 12? if you have a choice, you can either simplify before you start working with a fraction, or you can simplify later. It's probably going to be a little bit nicer to simplify as soon as you can. So does 12 have any perfect square factors? It does. 4 goes into it. So I'm going to actually simplify this fraction first. I'm going to rewrite it as 2 over, and then 12 is 4 times 3. The square root of 4 is 2, so this would become 2 times the square root of 3. Now it's up to you if you want to simplify, because we can simplify the 2's since they're both regular ordinary 2's. I'm not going to, normally I would, but I'm not going to just because I want to make it very clear what we do in the next step. So in the next step, to rationalize the denominator, we only need to multiply by the irrational pieces. 2 is already a rational factor. We don't need to worry about that. What we need to worry about is the square root of 3. So if I'm going to rationalize the denominator, I need to multiply this fraction by the square root of 3. We don't need to multiply by 2 times the square root of 3. If you do that, you're creating more work for yourself, because then you're going to have to go back and simplify again. So we multiply only by what's going to make the irrational part of the denominator rational. Now I have 2 radical 3 over 2 times 3. And then I can now, I could have done it before, like I said, but I just wanted to make that point very clear. We're going to simplify the 2's. And what do I have left? The square root of 3 over 3. In our next example, we have the square root of 8 over 54. In this case, we can simplify the fraction first. So we're going to simplify the fraction. 8 and 54 are both divisible by 2. If I divide them both by 2, I end up with 4 over 27. Now what I might do is I might split up the two. The numerator has its own radical, and the denominator has its own radical. So I'm going to say the square root of 4 over the square root of 27. And now I want to check to see, can I simplify one or both of the radicals? Yeah, the square root of 4, that's a perfect square. The square root of 4 is 2. And the denominator, 27, is not a perfect square, but it does have a perfect square factor of 9. So I want to think about 27 as 9 times 3. The square root of 9 is 3. So we end up with 3 radical 3. Now I need to rationalize the denominator. So I've simplified, I've taken care of all that, but I still have an irrational piece of the denominator. I don't need to worry about this 3. This 3 is fine because it's rational already. The square root of 3, however, is not rational. So to rationalize that square root of 3, I need to multiply by a square root of 3. I'm going to do the same thing in the numerator, and now I'm going to multiply. 2 times root 3 is root 3. In the denominator, root 3 times root 3 is a regular 3, and 3 times 3 is 9. I can't simplify because 2 and 9 don't have common factors besides 1.